Welcome to today's deep dive. Usually when you picture artificial intelligence, the image that comes to mind is, I don't know, this clean, futuristic, completely weightless cloud of code.
Right. Yeah, it just feels like magic.
Exactly. You type in a prompt, the screen blinks, and a highly complex answer just, appears out of the ether.
Well, the tech industry has actually designed the entire user experience to make the physical infrastructure of the digital world invisible.
Yeah, they want it to feel sleek.
Exactly. The processing happens off-device, so the result feels entirely ethereal. It feels like the internet exists nowhere and everywhere all at once.
But the physical cost of your next AI prompt is actually being paid right now in burning coal and evaporating water.
Yeah, that is the stark reality.
And that's our mission today. We're going to unpack this really eye-opening article by AI thought leader Johan Steyn. His piece is called Coal, Code, and Consequences, and it completely shatters this illusion of a winkless digital world.
It really does.
We're looking specifically at South Africa today, which is being aggressively courted to become Africa's premier AI and digital infrastructure hub.
Right. And for a nation navigating severe energy insecurity and, frankly, a deepening water stress crisis, being the hub of the future digital economy is an incredibly intoxicating promise.
I mean, it sounds great on paper.
Oh, absolutely.
Yeah.
It brings the prospect of job creation, technological advancement, and a massive influx of foreign capital. I mean, South Africa already holds the record for the most data centers on the African continent.
Wow, really?
Yeah, and the investments are only accelerating.
So reading through Stein's analysis, I couldn't help but picture this scenario. It's like, imagine a country buying a state-of-the-art, futuristic electric supercar.
Okay, I like this.
Right. It looks amazing. It has all the bells and whistles. It represents the absolute cutting edge of human innovation. But to actually make it run, they've quietly strapped a massive smoke-belching diesel generator to the roof.
That is exactly the core conflict Stan introduces. He focuses directly on that generator. Because if you're bringing in these massive, resource-hungry, hyperscale computing facilities, someone ultimately pays the physical bill.
Right. And we aren't just talking about the financial cost of construction here.
No, not at all. We are talking about carbon emissions, resource depletion, and the environmental ledger that's just being written in real time. You literally cannot have an AI revolution without an immense amount of electricity.
So let's dig into the mechanics of that energy paradox.
Yeah.
Why does AI require a fundamentally different scale of power compared to, the digital tools we've been using for the last 2 decades?
Well, it really comes down to the difference between retrieving information and generating it.
Okay, break that down for us.
Sure. So traditional computing, like a standard web search, is a relatively low-energy retrieval process. You ask a server to find a specific piece of data, and it sends it back.
Simple enough.
Right. But generative AI models rely on parallel processing. They typically use thousands of graphics processing units or GPUs running simultaneously.
So it's not just a quick fetch quest.
Exactly. When you give an AI a prompt, it isn't pulling a pre-written file from a folder. It's actively calculating probabilities across billions of parameters in real time to generate a completely original response.
Okay, so if a standard web search is like, say, asking a librarian to walk into the stacks and fetch a specific book you requested,
Yeah, good analogy.
then an AI prompt is like forcing that same librarian to read 10 million books simultaneously, cross-reference every single sentence, and write you a brand new original essay on the spot.
Yes, that is exactly what it's like. And that level of computational heavy lifting demands an exponential increase in wattage.
Which brings us back to South Africa.
Right. To understand the scope of this in South Africa, we have to look at an analysis published by Pinsent Masons that Steyn highlights.
What did they find?
Well, South Africa's data center sector faces a structural challenge because its national grid remains heavily dependent on coal.
Oh, wow.
Yeah. Over a third of national electricity generation comes directly from coal-fired power stations.
Meaning a megawatt consumed by a server farm in South Africa carries a significantly heavier carbon burden than a megawatt consumed in a country operating on, say, a geothermal or wind-powered grid.
Precisely. The grid mix dictates the true environmental cost, and the sheer volume of power we are talking about here is just unprecedented.
Give us some numbers, because the ones in the article were staggering.
So Steyn brings in a global projection from the World Economic Forum to set the stage. The WEF projects that by 2030, Global data centers will consume 945 terawatt hours of electricity.
Just to pause on that for you listening, 945 terawatt hours is more than the current combined electricity usage of Germany and France,
It's unbelievable.
entire industrialized nations.
Yes, and it's more than double the total global data center usage in 2024. The WEF notes that through 2030, AI alone could account for over 20% of total electricity demand growth globally.
20%.
Yeah, and the most concerning detail in that report is that fossil fuels are still expected to supply roughly 40% of that new demand.
That is, when I was reading through Steyn's notes on a report from TechCentral, and a hyper-local example jumped out at me that just puts this into terrifying perspective.
The Durban project, right?
Yes. There is a proposed 400 megawatt AI data center in Durban, backed by a South Korean consortium. This single facility would consume an estimated 25% of the entire city's electricity supply.
It's hard to even wrap your head around that.
1/4 of a major metropolitan area's power routed to a single commercial project.
And when a facility claims a quarter of a city's power, it stops being just a real estate development. It becomes a fundamental alteration of the region's public infrastructure.
It has to.
It forces a complete recalculation of how a municipality distributes its resources.
But wait, let me play devil's advocate here for a second. Isn't this just the standard growing pains of new technology? Didn't the early internet also require a massive scale-up in power grids and server farms?
That's a common argument, yeah.
Right, so it feels like we might be overreacting to a single proposed project just because AI is the current buzzword.
Well, the early internet comparison actually misses the core issue here, which is speed and density.
Speed and density.
Yeah. The rollout of traditional cloud infrastructure happened over a couple of decades, which gave grids somewhat of a buffer to adapt.
Okay, that makes sense.
But the computational density required to train and run generative AI models is forcing hyperscale projects like that Durban Center to arrive far faster than the regulatory and environmental frameworks needed to govern them.
Ah, so the rules haven't caught up.
Exactly. The investment is rapidly outpacing the government's ability to safely integrate these facilities into an already fragile grid.
And if a single building is pulling 400 megawatts of power, that energy doesn't just disappear once the computation is done.
No.
The first law of thermodynamics tells us it turns into heat. Millions of processors running parallel matrix multiplications at maximum capacity get incredibly hot. So how do these facilities deal with a thermal load of that magnitude?
Well, this is where they introduce the most alarming, yet frequently neglected factor in this entire equation: water.
Water, right.
Yeah, data centers consume enormous volumes of water to cool the servers. They don't just use standard air conditioning like you have in your house.
That wouldn't even make a dent, I imagine.
Not at all. To dissipate that much heat, hyperscale facilities rely heavily on massive evaporative cooling towers.
So walk us through the physics of that. How does an evaporative cooling tower actually work in this context?
Sure. Hot water from the server floors is pumped into the cooling towers. As this hot water is exposed to the air, a portion of it evaporates.
Okay.
Now, evaporation requires energy, and in this case, it pulls that heat energy out of the remaining water, drastically lowering its temperature.
So it chills the water left behind.
Exactly. The newly chilled water is then cycled back down to cool the servers. But here's the kicker. The water that evaporated is gone.
Gone.
Yeah, it has literally vanished into the atmosphere as water vapor. This is a consumptive process.
Wow. The Irish Times reported, and this was cited by Steyn, that by 2030, global data center water consumption will exceed 450 million gallons per day.
Staggering.
That is the equivalent of the daily water usage of 5 million people, literally evaporating into the air just to keep the internet running.
And bringing that global projection down to the local level reveals the immediate stakes for South Africa.
Let's talk about the local impact.
Steyn points to the Vaal Dam system, which supplies the entire Gauteng province. This system faces persistent structural pressure.
Because it's a water-stressed region.
Right. And in certain catchment areas there, power generation alone already accounts for more than a third of local water use.
Think about it. If a massive, sprawling facility drops into a water-stressed community, taking up acres of land and drinking millions of gallons of water from the public reservoirs every single day, you'd expect an absolute uproar.
You really would.
If an industrial farm moved in and drained the local water supply without producing a single crop of food for the community, people would march in the streets.
Ex
So if a single facility is draining that much from an already fragile area like Gauteng, how is the public not noticing this massive drain on their local reservoirs?
Well, the zero-sum reality of water security is heavily obscured.
Obscured how?
You see, the water actively cooling a server farm is water not flowing to a household tap, a hospital, or an agricultural center. But the public doesn't notice the drain because the actual consumption figures are intentionally kept out of the public domain.
Okay, yes. When I read this section of Steyn's piece regarding the Daily Maverick investigation, the legal rationale they used just threw me.
It's wild, isn't it?
It's insane. The investigation found a massive transparency problem in South Africa's data center sector. Eskom, which is the national public utility, and several municipalities outright refused to provide the electricity consumption statistics for local data centers.
And you know what they cited? Privacy legislation.
Privacy legislation.
Yeah, they used it to withhold the data. And it extends beyond just the local utilities, by the way. Several major tech companies frequently refuse to publish any AI-specific figures on their energy and water usage.
So nobody actually knows the real numbers.
Right. And without access to this empirical data, Steyn argues that governments and regulators are essentially flying blind. They literally cannot make sound decisions about infrastructure expansion or impose necessary conditions on these developments.
Using corporate privacy laws to shield raw utility consumption on a public grid seems like a massive reinterpretation of what privacy laws are built for.
It's a huge stretch.
I mean, I understand protecting trade secrets, sure. But hiding the fact that a commercial entity might be drawing a quarter of a public city's power grid or water supply, that feels like it crosses the line from privacy into just a deliberate infrastructure loophole.
It absolutely does.
Yeah.
And this lack of transparency protects a very specific economic dynamic. Researchers that Steyn cites warned of a structural inequity taking shapes, and they refer to it as digital extractivism.
Okay, before we go further into that, it is really important to note for you listening that we are just unpacking Steyn's arguments and the researchers he cites here.
Yes, absolutely.
We aren't taking a political stance or endorsing a specific geopolitical worldview, but this framing of digital extractivism is a highly charged critique that we need to understand to grasp his overall point.
Right, we're just reporting what the source material is saying.
Exactly. So what exactly does this extractivism look like in practice?
Well, wealthier nations in the global north are facing immense pressure from their citizens and regulators to lower domestic carbon footprints and meet these really aggressive climate goals.
Everyone wants to go green.
Exactly. But simultaneously, their appetite for digital services and AI compute power is skyrocketing.
So they need the power, but they don't want the carbon footprint.
You got it. To solve this math problem, they look for regions to host the heavy, resource-intensive infrastructure elsewhere.
And South Africa is viewed as a relatively stable, highly attractive investment destination on the continent, which makes it a prime candidate to host these servers.
Right. And just as historical empires extracted physical resources like minerals, agriculture, land from the global south, researchers argue that today's digital giants are extracting a different kind of resource.
A digital resource?
Well, a physical resource for a digital economy. They are extracting local water, local land, and the carbon budget of the global south to power the digital economy of the global north.
Wow.
So South Africa essentially absorbs the localized environmental damage so that users in other parts of the world can enjoy seamless, seemingly clean AI.
But wait, developing nations desperately want this investment, right? I mean, the host countries aren't just passive victims here. They are actively courting these data centers because they bring foreign direct investment, specialized jobs, and, the prestige of being integrated into the global tech economy.
That is the complex reality that makes this so difficult for policymakers.
It's a double-edged sword.
Completely. The economic incentives are very real and deeply needed. However, Steyn argues that South Africa needs to be incredibly clear-eyed about the long-term trade-offs.
They need to read the fine print.
Right. They must recognize exactly whose carbon footprint they're taking on and at what cost to their own domestic stability.
Which really brings us to the ultimate question. What does this actually mean for the people navigating this reality? Steyn breaks down the implications for three main groups: policymakers, businesses, and everyday citizens.
Yeah, let's start with policymakers. For them, Steyn is unequivocal. Simply attracting foreign investment cannot serve as the sole metric of success.
It's not just about the money.
No. South Africa urgently requires a comprehensive environmental framework, specifically tailored for hyperscale data center development.
And the guardrails he lists are very specific. He calls for mandatory reporting on water and electricity consumption, which would completely eliminate that privacy law loophole we talked about.
Which is crucial.
He also outlines the need for binding efficiency standards and clear, non-negotiable requirements for renewable energy procurement.
Because without those regulatory frameworks, South Africa risks dramatically deepening its coal dependency at the exact moment its international climate commitments demand a pivot away from fossil fuels.
It's a massive contradiction.
It is. It's a policy contradiction that threatens both their environmental standing and their long-term energy grid stability.
And then, for the businesses and investors building these centers, the landscape of global sustainability reporting is tightening rapidly.
Oh, yeah.
Building highly carbon-intensive digital infrastructure carries growing reputational and regulatory risks globally.
Right. And Steyn suggests this is where South Africa's data center sector actually has a genuine strategic opportunity.
How so?
Rather than viewing transparency and clean energy adoption as just a nagging compliance burden that they try to minimize, they could choose to lead the continent by making it a strategic priority.
So flip the script.
Exactly. Establishing a reputation for sustainable, transparent data infrastructure would make them far more resilient to future global regulations.
Finally, Stan addresses everyday citizens. And the stakes here live the realm of abstract policy debates and corporate balance sheets pretty quickly.
They're immediate.
Very immediate.
Yeah.
Water security in a place like Gauteng is literally the water coming out of your tap.
Right.
The decisions being made today behind closed doors about how these data centers are powered and how much of the public's water they are allowed to consume will permanently shape household water availability for an entire generation.
Ambition without accountability is a liability that future generations will inevitably inherit. That's the reality.
That's a heavy thought.
Stan actually closes his piece with a profound realization. The servers are being switched on across the country right now, today, and the environmental ledger is being written whether or not we choose to read it.
Because coal does not magically become clean just because it is powering a high-tech 21st century data center instead of a 20th century steel factory.
Exactly. And water does not become abundant just because it is evaporating to cool a sleek server rack instead of irrigating a field of crops.
The physics don't change.
The physical reality, the thermodynamic cost, remains exactly the same. Stan's ultimate point is that for the sake of the populations who will have to live with both this new digital economy and its climate consequences, host nations must insist on transparency.
They have to.
They must refuse to let the promise of foreign investment override the fundamental duty of resource stewardship.
It really grounds the entire conversation in physical reality. We are treating AI like a software issue when it is fundamentally an infrastructure issue.
That's the perfect way to summarize it.
So to wrap up today's deep dive, I want to leave you with a thought to mull over that pushes just a bit beyond Steyn's article.
Okay, let's hear it.
We've talked about the hidden local costs of these data centers, but think about the geopolitical future of this setup.
Things could get complicated.
Very. If AI becomes as critical to global economies as, say, oil or international shipping lanes, at what point do sovereign nations start viewing data centers not as corporate real estate, but as the equivalent of foreign military bases?
Oh, wow.
Right. If a severe drought hits a host country and local water reservoirs run dry, could a tech giant suddenly throttle the processing power of hospitals or financial markets half a world away just to keep their servers from melting down?
That's a terrifying hypothetical.
When our digital lives are physically anchored in someone else's fragile ecosystem, we really have to ask who really holds the power when the water runs out.